generally, yes. So today we are going to discuss about the system of linear equations. Uh, it is quadratic equations are linear equation. Quadratic equations means like that is in the form of ax square plus bx plus c equal to 0. But system of linear equation means like in the form of like see a1x plus b1y, okay, equal to c1. This is a2x plus b2y and c2. So how we can solve this two linear equations? So we are eliminated either x, either y, okay, either x, either y, and we are getting y value, and next we are getting to that x values. Okay, so but in the three simultaneous linear differential equations will be there. So that a1x plus b1y plus c1z equal to d1, and next a2x plus b2y plus c2z equal to d2, and next a3x plus b3y plus c3z equal to d3. Okay, so these are the system of equations. So this system of equations, how we can convert into the matrix form. Okay, so here this the coefficients will be there. That's we can write that the coefficients of x in the three equations. So that is a1, a2, and a3. Okay, next similarly that b1, b2, and b3. Next c1, c2, c3. This is a. Next that x means we need to find the values. That is x, y, z. So we have to determine it. And the b equal to, that is d1 and d2 and d3. Okay. Now this completely that equations that we can write ax equal to b. Okay. So ax equal to b. So this is system of that linear equations. Okay. Now we here in this chapter in the numerical analysis. Okay. So what are the how many methods we can solve this system of linear differential equations? Okay. So there will be methods will be there. The first is the Gauss-Jordan elimination method. So Gauss-Jordan elimination method, and Jacobi and Gauss-Seidel. Gauss-Seidel. So we are solving the system of equations using this one more. Okay, and it's very easy. So we can find out that easy iterations method. So using the iterations method, and we can get it the values of this all these things. Okay, and we'll do one problem. So Gauss-Seidel and Gauss-Jacobi. So I will explain one problem. And next, one more thing, that's inverse of matrix. That's no inverse of matrix. Yes. Okay. Now, first we go to that easy method, that inverse of matrix. So that inverse of matrix. Yeah. So this we know that in the previous studies, like in the UG level and PG level. So how we can find that inverse of matrix? Uh, See that the first is that A is a square matrix of order n. So that means, so A by is a n by n matrix. That means the number of columns equal to the number of uh, uh, rows. So that is A is at n by n matrix. If that determinant of A is not equal to 0. So in the previous studies, we know how to find the determinant, the matrix determinant from the in the 10th class standard also we have that determinant of mod A. Okay. Next, then 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 A inverse equal to, see listen, that A inverse equal to 1 by mod A into adjacent A. Okay, mod A into 1 by A into adjacent A. So how we can find the adjacent A means, so we need to find that minor of that matrix Mij. So we need to find the cofactor of elements of A is that is called that adjacents of the A. So this is the adjacents of A. A equal to what is that? That is cofactors. So cofactors of all the elements of A equal cofactor of all the elements of A. So that is adjacent same. Okay. So we need to find that cofactors of our matrix. So how we can find that cofactors matrix means? So that is Aij is a suppose one element that we can write that minus one whole power of 1 plus j, I plus j, sorry, I plus j, and the matrix of the co-elements of A. And the matrix of cofactors of A. Okay, so this is the thing. Just this is in the lower class also will be there. No? So what is that inverse matrix means? That A inverse equal to 1 by mod A into adjacent A. Okay, so this is the things. So we will do the one problem. Your example problem is there in your from textbook. if a equal to 1, 2, -1, 3, 6, 1, 3, 3, 2. Okay. Now find A inverse. Okay. So first we need to find the determinant. So see the solution. So find the determinant of A. That's we can write mod A. So mod A equal how we can write 1 into this row and this column that become 6, 1, 3, 2. Okay. And next. Uh, next. Next in -2 into this row, this column. So that becomes 3, 1, 3, 2. Next here that -1 will be there. No? So -1 into. So -1 into 3, 6, 3, 3. Okay. So from there, 1 into the cross multiplication. 12 minus 3 and -2 into 6 minus 3 and this one -1 into 9 minus 80. Okay. So this is become 9 minus 6 minus 3. 6 minus 3, 3. 3 into 2, 6. Next, 9 minus 18, -9. So already here minus is there. So that has become +9. So 18 minus 6, that equal to 12. Now we need to find the minus or cofactors of the each element. Okay. So we need to find the cofactor of the each element. So first, I will tell one first element, one cofactor. First, I will draw the here the given matrix A equal to that is 1 minus 2 minus, sorry, 1, 2 minus 1. Next, 3, 6, 1 and 3, 3, 2. Okay, so first this element cofactor. So that become cofactor of the the cofactor of the 1. So how we can determine it? See, so we have to eliminate this row and this column. So what is that? 6 into 2, 12 minus 3. So that equal to 9. Okay. Next. Oh yeah, sorry. 1, 3. Next, the cofactor of 2. Okay. 2 means this row and this column. And now do the cross multiplication. So what we are getting? 6 minus 3. That we are getting 3. Okay. And next, the cofactor of minus 1. Okay. Um, the cofactor of the minus 1 means 9 minus 18. So that's we are getting that minus 9. Okay. So like this, we need to find that all the factors of these things, and we have to use put the plus and minus alternate. So this is plus and this is minus. So already this is plus means already is there no. So minus 9 we are writing the as is. Okay. That before that we can write minus 1 whole to the power of I plus j. I plus j. So this is A11 first row first and first row second element. So this is the part will be there. So next, the Gauss-Jordan method. So the Gauss-Jordan method. Okay. So how we find the Gauss-Jordan method means it is a simple method for the numerical to find the inverse of the matrix A, and when A is a non-singular matrix. Okay. Just what is that? We have to make the reduce that equation. Uh, how we can find the inverse means first we have to make suppose A is a the first step is that A is a n by n matrix. Okay, so we are writing the argument matrix. Okay, that we can write A mod of I. Okay, so this is uh, next. So this is that. So using elementary row operations, row operations or column operations. So we change A to I identity matrix. We change that is A to is what is that? Identity matrix. Okay. So the important things that A to I. So that the matrix A, we are changing to the identity matrix. A, we have to change it to the identity matrix using the rows and uh, elementary operation, rows operation or column. So the write the first problem. Find inverse of matrix A equal to 1, 1, 1, and 4 minus 3, sorry, 4, 3 minus 1, and 3, 5, 3. So by Gauss-Jordan. Okay, so this is a 3 by 3 matrix. So first we can write the argument matrix. Save the- And see the solution. So we are writing that argument matrix that equal to A. Okay. So that equal to A means what is that? 1, 1, 1, and 4, 3, minus 1, and 3, 5, 3, with that identity matrix 1, 0, 0, and 0, 1, 0, 0, 0, 1. Okay. See, what is the next step we are doing? Is interesting. We are interchanging. Okay. So if you are doing the interchanging, so automatically here also that interchanging will be there. So 4, 3, minus 1, 1, 1, 1. And down is as it is the 3, 5, 3. That is 0, 1, 0, 1, 0, 0, 0, 0, 1. Okay. Now, apply that the next step. Do apply 1 by 4th into R1. So why? Because, so first we have to make this is as a 1. So when it is coming the 1, if you are doing that 1 by 4th. So that implies it is become 1 minus 3 by 4. Sorry, plus 3 by 4 minus 1 by 4. Next 1, 1, 1, 3, 5, 3. In the same way here, 0, 1 by 4, 0, and remaining is as it is 1, 0, 0, and 0, 0, 1. Okay. And next two, so we have to make this 2 is 0. This also we have to make this 0 and 0. So when it is coming, so it is already 1 now. So R2 minus R1 and R3 minus 3R1. So that implies, so what we are getting 1 and 3 by 4 and minus 1 by 4 and 0, 1 by 4, 0. So we are getting here also 0, 0, 1 by 4 and we are T5 by 4. Similarly, here also we are changing now. So 1 minus 1 by 4, 0. And next 0, 1, 11 by 4 and 15 by 4, 0, minus 3 by 4 and 1. So next we need to make the this part is 0, no? 1, 1, 1. So if you are taking that and later we have to do the 4 R2. So what we are doing that R3 minus 11 R2. And then we have to do the 4 R2 also. Uh, so from there we are getting that 1, 3 by 4 minus 1 by 4 and 0, 1 by 4, 0 and 0, 1, 5, 4 minus 1, 0 and 0, 0 minus 10 and minus 11, 2, 1. So the next thing, we should follow this step now here. R1 minus 3 by 4 R2. Okay. And after that, R3 by minus 10 and R1 plus 4 R3 and 2 minus 5 R3. So if you are doing this, all these operations, so then we are getting that 1, 0, 0, 0, 1, 0, 0, 0, 1 and 7 by 5, 1 by 5 minus 2 by 5 and minus 3 by 2, 0, 1 by 2 and 11 by 10 minus 1 by 5 and minus 1 by 10. So now this part is there, no? So this part is become what is A inverse. So this is that matrix inverse method by using the Gauss-Jordan. So, so what is the Gauss-Jordan method? Means we are taking to the arithmetics AI. So we are changing into IA. So this is become the inverse of A. So this is the things. So this is the called the inverse. So this part is called what is it? The inverse of 8. Okay. So this is inverse of matrix A by using Gauss-Jordan method. Okay. Next, Gauss-Jordan method of solving the differential equations. Sorry, Gauss-Jordan method. Also, how we can find the system of the linear differential equations. Um, so that's we are going to find out Gauss-Jacobi and Gauss-Seidel iterations method. We'll do one problem. So we are following the some systems. So I will explain the step by step. Okay. See, Gauss-Jacobi, Gauss-Seidel iterations methods. So the iteration methods. Okay. Now see the first step. So first, every equations. So we are changing in the form of that AX plus B. Initially, we discuss how we can change is that is AX plus B. Okay. Okay. So the rewrite that relevant system AXP, identify the matrix L, U, and D from A. Okay. Then find the matrix of H and C as how we can find from here. So we can find the matrix of L, L and D and U. So when you are doing the problem, so we can easily find out that from the matrix A, from here that matrix A, so we can find that L, D, U. Okay. From there, then find H, then find H equal to. So what is the H value equal to? That H equal to minus D inverse L plus U. Okay. And C equal to D inverse into B. So this is the procedure is also important. So from the matrix A, so we need to find L, D, U. From there, you can find the matrix H. H is minus D inverse of L plus U and C equal to D inverse into B. From that iterations, so we are find out that how many that iterations are reduced? X power of k plus 1. So the k values is starting from 0 to 0, 1, 2, 3, so on. So that equal to h into x power of k plus c. And where k equal to 0, 1, 2, and so on. In second approximations, and we can find out from that. So this we can find out. Okay. So write the one problem. Solve solve 8x1 plus x2 minus x3 equal to 8 and 2x1 plus x2 plus 9x3 equal to 12 and x1 minus 7x2 plus 2x3 equal to minus 4. So just we are doing the interchange. Second to third. Okay. That is R2. So from there we are getting that 8x1 plus x2 minus x3 equal to 8. Next x1 minus 7x2 plus 2x3 equal to minus 4. Next 2x1 plus x2 plus 9x3 equal to 12. From there we can write d equal to 8, 0, 0, 0 minus 7 0 and 0, 0, 9 and L equal to the lower triangle matrix 0, 0, 0, 1, 0, 0 and 2, 1, 0 and the upper triangle matrix and 0, 1, -1, 0, 0, 2, 0, 0, 0. So this the previous we discussed no LUD. So that if you are adding that A equal to L plus D plus U. So we are getting to the same thing. So that 8, 1, -1 and next to 2, the 1, -7, 2. This is so from there P inverse equal. So you know how to find that inverse. 1/8, 0, 0, 0 -1/7 and 0 and 0, 0, 1/9. Then L plus U. So we should add the L and U. And we are getting 0, 1, -1, 1, 0, 2, 2, 1, 0. Then we need to find the H equal. D inverse into L plus U. And find the C value also. So D inverse into B. So then the iteration is become the x power of k plus 1. Just now we discussed, no? That's we need to find it. C and H. X power of k plus 1 equal to H into x power of k plus C. And k equal to 0, 1, 2, 3, 7.